In this video, we're going to look at linearising equations. This is a very important point for physics practicals. What we'll often do is we'll give you an equation to test, and then you have to figure out how to plot a linearised version of this graph in order to read off a gradient and an intercept, to plot max and minimum gradient lines, to do all kinds of analysis. So, first off, if you want a linear graph, you will expect it to have the equation that looks a bit like this: y equals mx plus c, i.e. the thing you've plotted on the y-axis is some constant times the thing you've plotted on the x-axis plus some intercept, some other constant. Let's take the relationship between the voltage, the current, and the resistance as our first example. This is already in the form y equals mx plus c. If we were to be looking at the resistance of a fixed resistor, so we would have something we can vary, something we can measure, and a constant. So if we rearrange this equation, V equals R times I, we can always rearrange the order things are multiplied, just as 2 times 3 is the same as 3 times 2. So here we have some variable is some constant times some other variable. So if I'm going to plot the voltage on the y-axis, I'm going to write y equals mx plus c underneath it. Okay, this looks like it now. So here we go. I've got the voltage I can plot on the y-axis. I've got the other variable, the current, which I can put on the x-axis. I've got some constant, which is the resistance. Now, I've got nothing here. I can always write a plus 0 on the end of an equation. So I'm expecting an intercept of 0, i.e. a straight line that goes through the origin. So here we have it. Rearrange the equation such that you've got a variable is a constant times a variable. The gradient is the constant here in front of the variable, and the intercept is this other constant here that we wrote in. That was our first example. Just going to remove that. Now we're going to look at another example. So in this one, the current is the charge passing divided by the time taken. So this, let's say we were going to be, well, our two variables are given for us here. So what we're going to do is we're going to plot the charge passing on the x-axis and the time taken on the y. So presumably we are going to be keeping a fixed current and looking at how fast charge passes. So what we need to do is we need to rearrange this equation so as it looks like variable is constant times variable plus constant. So I is our constant here. So let's rearrange. We can pull t up, y-axis, we should have t on the y-axis, so t needs to be sat on its own. T equals q divided by I. Now, this is the same thing as writing t is 1 over I times q. And I can always add a plus 0 on the end, so we are now in the right form. Y equals mx plus c. Let's connect our things. So we said we'd have the time on the y-axis. We'd said we would have the charge on the x-axis. We've got some constant, which is 1 over the current, and we've got the intercept, which is some other constant. So that means we can write the rest of this. The gradient should be 1 over the current, and the intercept should be 0. You can do all the rest of these in exactly the same way. You rearrange the equation so as it looks like y equals mx plus c, and then you figure out which things you want to plot where. So there's lots of examples. Eventually you might need to use logs, using the laws of logs, and various other mathematical tricks, but all you're aiming to do is convert an equation such that it looks like a constant. a variable rather, is a constant times another variable plus a constant.